All right, so we're starting Unit 6, and the first lesson is on the Law of Sines. So this is, we're not going to spend 2 days on this. So this is just lesson 6.1. And the Law of Sines is used to solve oblique triangles. And you may remember what an oblique triangle is from geometry, but an oblique triangle is a triangle that has no right angle. So any triangle that's not a right triangle is an oblique triangle. So these are triangles that have no right angle. So we can still use trigonometry kind of without a right triangle, which is what we're going to do with the law of sines and then the next lesson with the law of cosines. So one thing that you're going to need to know, like in the grand scheme of things, is when to use law of sines and when to use law of cosines. So you use law of sines if you know either two angles and any side, which would be angle, angle, side, or angle, side, angle. Or if you know two sides and an angle opposite one of them. So that's going to be like side, side, angle. Be careful you don't spell that the other way. And to know for sure that it's the angle opposite one of them, the angle letter should match one of your side letter. Okay, now the law of sines and the law of cosines are two things that are on the challenge exam reference page. They are also, whenever they give you an ACT question with law of sines and law of cosines, they give you both the law of sines and the law of cosines. So mainly you need to know how to use the formulas and when to use which one. So that's what we're going to hopefully get straight this week. Okay, so for law of sines, I'm going to write it like they do on the challenge exam reference sheet. It's the sine of angle A, so it'd be capital, over side A, so it'll be lowercase, is going to be equal to the sine of angle B, which is capital, over side B, which would also be equal to all that stuff with C. Now, we're never going to do 3 ratios. We're just always going to do 2, depending on what you're given. And if you put the side over the sine of that angle, it's still going to work out too. So if we flip these over, it would still work perfectly. All right, so we're going to be dealing with acute angles and acute triangles and obtuse triangles. So I just picked ABC as my angles. And then the side opposite of angle A, you need to make sure you call side A. And the same thing for opposite of B is side B, opposite of C is side C. If you mess that up, you're going to be doing the wrong problem and it is not going to come out correctly. All right, same thing here. Opposite of angle A is side A, and B and C also. All right, so let's do one of these problems. So on number 1, we're given angle A is 123 degrees, angle B is 41 degrees, and side A is 10 inches, and we're going to solve the triangle. All right, so this one goes with the first possibility, 2 angles and any side. So in that case, we are going to use law of sines. So what I'll do is I'll do the sine of angle A, which is 123 degrees, over the length of side A is equal to the sine of angle B, which is 41 degrees, over side B. Right? And then this is just a ratio that we're going to solve for B. So you would start off by cross multiplying. And then divide by the sine of 123 degrees. And that's going to be your answer. So B is equal to 10 sine of 41 degrees over the sine of 123 degrees. And technically that's in inches, so we'll put that there. Now we are not using a graphing calculator, so that's all we can do. We can't figure out what that is, and it's fine. It doesn't matter what it is. Okay. Now, if you guys remember from right triangles, when we're solving an angle triangle, we're finding all the angles and all the sides. So I need to find angle C and I need to find side C. So angle C is not difficult to do. We just know there are 180 degrees in a triangle, and we'll subtract the two angles we know, and that should leave you with angle C is 16 degrees. And then lastly, we need to find side C. So to find side C, we're going to do the law of sines, where I will say that the sine of 123 degrees over the length of side A is going to be equal to the sine of angle C, which is 16 degrees, over side C, which is what we're looking for. All right, and so it's just like what we did at the beginning of the problem. We're going to cross multiply and divide. And we'll get that side C is 10 sine of 16 degrees divided by the sine of 123 degrees. That's it. That's law of sines. Law of sines is awesome. Okay, and then example 2, we're not going to solve the whole triangle. We're only going to find angle B. All right. So on this one, we're given two sides and an opposite angle. Now, the reason I know it's an opposite angle is because I have angle A and I have side A. That means they're opposite of each other. So in this case, I'm free to go ahead and use law of sines. And so what I would do is I would say that sine of angle A over the length of angle A is equal to the sine of angle B over the length of angle B, which, that is 5. Okay, so I will just go ahead and cross multiply. Right, and then I would divide by the 21. All right, and this is what the sine of B equals, but I don't want the sine of B. I want what actual angle B equals. So when we know what the sine of an angle is and we want to find the angle, that's where we do the inverse sine. So b should be the inverse sign of that fraction. It's a weird looking parentheses. Okay, so that's the law of sines. All right, so your assignment is down there at the bottom, and I did change the directions. So on those specific problems, you're only finding one thing. You're not finding it all, and we're not using the calculator, so your answer should be similar to what we've been getting in the example.